as a scientist or researcher, you want to produce tables that actually meet particular standard, such as APA tables. And most of the times, instead of just analyzing your data in R and having to go and write your table manually in Microsoft Word, what happens if maybe your editor or your reviewer requests an adjustment? You have to still go and run the analysis and rewrite your tables again. So this is why we have packages like APA tables. So we just generate APA compliant tables, so tables that meet the APA standards directly inside R. So we're going to be going to the APA tables. So go to the APA tables file. So first of all, you need to install it if you don't have it. Install the APA tables library. Once you install that, then we're now going to be loading it. So we're going to be using the Viagra dataset. So the Viagra dataset is a built-in dataset inside R. We are going to load the Viagra. So this just have a view of it. So this is the Viagra. We have two columns. One is dose and the other one is the libido. So placebo, let's check the number of dose that we have. Table Viagra, then dose. Okay, sorry, it should be dose. So for placebo, we have 5. That is 5 are on placebo, then 5 are on low dose, while 5 are on high dose. So this is it. So this is just more or less like, and this is the libido. Now we want to create a ANOVA table. We want to call a one-way table. We want to create a one-way table. So this is a one-way table. Let's run it so that I can see the output. You can see this is a one-way table. We are creating a one-way ANOVA table. So what you actually, an ANOVA table, if this is new to you, check my biostatistics, practical biostatistics with R course. I explained a lot and in details about analysis of variance, especially one-way ANOVA. So one-way ANOVA allows you to be able to know the differences in significance between 3 or more groups. So you can see we have high dose, low dose, and placebo. If you want to know whether there is a significant difference between the libido of these particular 3 groups, use the one-way ANOVA table. So I explained a lot of it in my practical biostatistics with R course. So ensure you check it if you are not familiar with this statistical terminology. So our independent variable is dose, and our dependent variable is libido. So this is our independent variables which are actually interested in getting, which is our placebo. So now the data we're specifying, which is the Viagra data, and so they were each given Viagra. Each of these groups were given Viagra, and their libido was now recorded. So we want to now see among these 3 groups, which of them were the reaction of their libido equal among the 3 of the groups, or it wasn't equal among the 3 of the groups. So that is where we are using the one-way ANOVA table. So you can actually do this manually using the AOV function in R. But if you want something that is APA ready, then you have to use the APA.oneway.table. So this is something that you can actually export directly to Microsoft Word or maybe to your presentation. So we are going to show confidence interval. There are also other arguments, but these are just the necessary ones. That's the basic minimum requirements that you can need to get your table ready. And table.number, we're giving it table number. So when you run this, you have this as you are seeing. So you can see this is the confidence interval. This is the mean confidence interval of each particular dose. So, and you can see that out of all of this is the only one that is not significant, because there is 0 in between the confidence interval. So this and these are both significant. So that is just statistical terminology. You can check my course to learn more about that. So our table is already ready. And this is also another data set we want to use to build a correlation table. So I'm just going to be running these two also. We're going to be getting a correlation table. So I run this here. Okay, I think we still get the same output. So this is the correlation table. I'm going to be expanding it. You can actually reformat this using the cable and the cable extract, just like I explained earlier on. So there's still other better ways of doing your tables. that will make a publication ready, but some people can still decide to go for the APA tables. So we can see table 3. This can see our correlations between complaints, privileges, raises, critical, advance. We have not actually even looked at the attitude data set, so let's have a look at it. So these are our columns: ratings, complaints, privileges, learning, raises, critical, and advance. This was recorded from various individuals. I think these are various scores. So, and we check for the correlation. You can see this is what we have. And also we have another data set now called the album. Also another inbuilt data set, album. So this one has four columns: adverts, the sales, airplay, and the attraction. So these are the various columns, and we want to create a regression of the adverts, airplay, and sales. So we're going to be using our regular LM function. We get our model, and once we get that model, we are going to be using it in the regression.table function, apa.regression table function. You give in your model and your table number, which is table 4. Then we call it. So once we do this, you can see we have a nicely looking APA formatted table. You can see in APA formatted table, you can see our estimates. This is an indication of statistical significance. If you want to use a maybe cable, you can. This is where your footnotes can come into play. And this is our confidence and interval. So you can see it. This is our beta. And this is also other outputs that we have in this table. If you want to learn more on the regression model, also check my practical biostatistics with RCOS. I have a lot of information there on regression, how you can interpret it. So this is also another one too. Also, I can use it to show 2 regression tables. This time around, I'm having 2 regression tables. This one without interaction, and this one that is interaction. This is actually interaction between adverts and airplay. So, and this is my regression table. So when I call this, I'm able to see my 2 regression. Look at how important this particular function is. It combines 2 types of regression for you instead of creating separate regressions. First one is with interaction, second one is without interaction. So this is the interaction. You can see the significance of the interaction inside this particular table. So there are other functions, there are other arguments in this function, but you can actually learn more if you check the online documentation or just explore documentation. But most of the times, these are even okay for you to get started if you are not an heavy user.